Well, welcome to your impulse homework. The thing to keep in mind is impulse is equal to two things. It's equal to the force on an object times the time that force acts. It's also equal to the object's change in momentum. So we often write it this way. The change in momentum equals force times time. They both mean impulse. So I have two people jump off a cliff. One lands in the water and sadly the other one lands on a large rock, which is why you don't jump off cliffs. And I want to use the concept of impulse to explain why the person who lands in the water feels better. And the answer is simply because when you land on the water, it stops you over a longer period of time, and therefore less force is applied. So one way of thinking of it is that if you have a certain change in momentum that's going to occur when you hit the water, right? But if there's a longer time involved, then the amount of force required is going to be significantly smaller. Okay? And similarly, I have two cannons launch projectiles of equal mass. There's a good control variable, equal amount of force. We have another control variable. They're both shooting the same angle. Man, we got all these control variables. Here's what's different. The longer the barrel sends the projectile farther, and the question is why. And again, the answer lies here. Because what's going to happen is this. I'm just going to use an equation. You can use words in your homework. Alright, so in order to make it go farther, it has to have a larger change in momentum. So how is it? So let's just look at the cannon with a short barrel. The cannon with a short barrel makes a fairly small change in momentum, and the reason is because we have a certain amount of force, but it acts over a short amount of time. So if we look at the cannon that sends it, so I'll put this one, I'll say short distance. But the one that sends it a far distance, look what happens. We have the same mass, but a much larger velocity. And why do we get a larger velocity? Well, it was able to accelerate more. Why? Because the same amount of force, I'm going to try to make my F the same size as it was over here. So the same force, but in this case, because the barrel is longer, it acts over a greater amount of time, and therefore it's able to achieve a greater velocity and go further. That's like why you follow through when you hit a baseball or a golf ball. All right, let's try number 6. Here's the mass of the person, here's the velocity, here's the time. Hey, how much force? I'm simply going to use this equation and substitute in. So what I've got is the mass of the person is 75 kilograms times the velocity the person acquires is 20 meters per second, and that equals the amount of force applied divided by the amount of time it was times the amount of time it was applied for, which is 0.15 seconds. And when all you had to do, and the impulse equation is nice because all you had to do is take the variable you're looking for and divide by whatever it's being multiplied by. There's never any variety. It's always going to be two things multiplied divided by the other thing. So 75 times 20 divided by this, what that gives me, whoops, that gives me is the force equals, hang on, let me look at my answer key so I don't know how to get out my calculator. I'm so lazy. Oh yes, 10,000 newtons. Alright, let's keep going here. Oh, darn it. Hang on a second, I'm going to duplicate this page. Okay, look, my 75 kilogram man is back again. He's still flying at 20 meters per second like he was before, but this time, instead of landing on the ground, he's going to land on a trampoline and stop over this much time, which, let's face it, that's an unrealistic amount of time, but hey, I'm just trying to teach you some physics concepts here. So again, we're going to do the same thing, and we're going to see there's a lot less force involved because there's a lot more time involved. So we have 75 kilograms times 20 meters per second. This time it's going to be the force, and this time the force is times 2.34 seconds. So I'm going to take these values here, multiply them together, and it's going to be 1500, and I'm going to divide it by this instead of by that. So since I'm dividing by a bigger number, I get a significantly smaller number. The force applied this time is only going to be 641 newtons. Not too shabby. Alright, let's try the next one. Let's just look at what I'm trying to find. I have mass, I have force, I have velocity, and I'm asked to find out how long. That's time. So in this case I'm solving for time. So I'm going to say I have a 1500 kilogram motorcycle, and it's going to accelerate to a velocity of 38.4. Now, I don't really care about acceleration in this one. I just care about the actual velocity we end up with after a certain time period. Equals the amount of force being applied to the motorcycle is 4,800 newtons times the amount of time. So if I wonder how long it took, all I have to do then is multiply these together and divide by that, and that will solve for time. So in this case, time equals 12 seconds. So the real trick to these problems is not mathematically. I mean, mathematically you're always going to have a variable you're looking for multiplied by some number, and you have to divide by that number. They always solve the same. The trick here is, honestly, you just have to know your units. Kilograms is mass, newtons is force, meters per second is velocity, and seconds is time. Let's just try going with the next one, number 9. Alright, let's just look what I'm trying to find. It says, what is the mass of the cannon? I'm looking for the mass of the cannon, so I should know everything else. Let's just see here. I'm going to try to substitute into the equation this way. The first thing I have is, this is the force applied by the cannon, 17,000 newtons. Okay, and then it takes, here's how many seconds it takes to leave the barrel, so I'm going to put that here, force times time, 0.034. This kind of looks like a person's face, doesn't it? Didn't mean to. Alright, and then let's see, it goes backwards at this many meters per second, and I want to know what its mass is. So I'm looking for mass, and I'm going to multiply this by 3.8 meters per second. I'm going to simply say this times this and divide by this, and when I do, what I find is the mass is going to be 152 kilograms. That's quite a cannonball, I must say. Oh, that's the cannon, no wonder. Okay. Let's move on. Oh my goodness, what a short homework. How nice is that? The end of the year must be approaching. Actually, there just wasn't much I could ask about impulse, even though it's an important idea. Okay, let's try this one here. Oops. Here's how much force is the maximum force the human body can be subjected to without serious injury. I looked that one up on the internet. I hope the internet told me the truth. Let's see, the maximum velocity a 65 kilogram astronaut can be accelerated to in 60 seconds. Oh, hey, I guess NASA had to figure this out, huh? We don't want to hurt our astronauts. We don't want to apply any more than this much force to their body. So what we're looking for is, let's see, what is the maximum velocity? So I'm looking for velocity in this equation. So I have to know the mass of the astronaut is 65 kilograms times velocity, which I don't know, equals the force I'm going to apply. Sorry, astronaut, I guess that's a lot of force to apply to you, times the amount of time we're going to do it for. How fast does the person end up going? Again, we just multiply this by this and then divide by this. And when I do that, I find I can get that person going 1,246 meters per second. Yahoo! Alright, last one. Oh, that balloon launching catapult of mine. I love that one. It applies a force of approximately 168 newtons. The balloons have a mass of 0.2 kilograms. And they leave with this much velocity. Hey, these are like pretty realistic values here. Okay, so how long were they being launched for? So I'm solving for time. Here we go. The mass of the kilograms is 0.20 kilograms. The velocity that they come out at is, we determined to be 27.83. Actually, it was less than that this year, wasn't it? Meters per second. I made it less fast to get better accuracy, sorry. And then the force being applied is 168 newtons. And what we want to know is how long were they being fired for? So once again, I'm going to say this times this and then divide it by that. And you can see it's not going to be a very big number because this times this is not going to be very big. And then I'm going to divide it by the largest number of the three. And so what that gives me is the time is going to be 0.033 seconds. Okay, that was it. That wasn't so bad now, was it? By the way, there's a good web help video to help you understand this. I mean, the concept, not just the homework.